Hello teachers, Diyos marhay na aldaw po sa gabos. We are on our 5th session of our most requested number theory tutorial. So we are done with CRT, Chinese Remainder Theorem, Linear Congruences, FLT, Fermat's Little Theorem, and Wilson's Theorem. At ngayon po, we will discuss about Euler's Theorem. But before we start, let us recall first our FLT. So we have this formula for FLT. A raised to P minus 1 is congruent to 1 mod P, where P is a prime number and A is a positive integer not divisible by P. So, kay Fermat's po, para sa prime number lang ang ating modulo. So, ang modulo po natin dito ay prime number lang. Pero, kay Euler's po, pwede ang prime at composite. So, kailangan po natin itong ma-master. Ano po ang formula natin? We have A raised to P, P po ang basa nito, PHI, times N, which is congruent to 1 mod N. This P times N is also called as totient of N, kasi ang tawag po natin dito ay Euler's totient function. I-discuss din po natin maya-maya. Kailangan po dito ay positive integers ang ating A at N. That is why pasok po ang ating prime and composite dahil tanging positive integers ang kailangan para sa ating A and N. But wait, kailangan din po pala na relatively prime ang A and N. Ano po ang ibig sabihin? Dapat po ang kanilang greatest common factor or GCF ay equal to 1. Yan po. So, ito po ang ating formula sa Euler's Theorem. But we have rules to follow para po dito sa ating Euler's totient function. Rule number 1. We have totient of N, so ito po yan, is equal to N minus 1 provided that N is a positive prime number. So, ang rule 1 ay para sa positive prime number. Rule number 2, we have totient of PQ is equal to totient of P times totient of Q, where the GCF of P and Q is equal to 1. Hence, relatively prime din po. Rule number 3, we have totient of R raised to S is equal to R raised to S minus R raised to the quantity of S minus 1. Where R raised to S is a prime power. Ibig sabihin po, ito pong R ay prime number. Then, with power, kaya prime power. So, ito po ang ating tatlong rules. Para mas malinaw, i-discuss po natin isa-isa. Rule number 1, totient of N is equal to N minus 1 such that N is a positive prime number. So, example, we have 3 raised to 28 is congruent to X mod 13. Our A is 3 and our N is 13. Pareho pong positive integers, so correct. 3 and 13 dapat po relatively prime. So, paano po natin i-check? 3 and 13 at siya rin po ang andito. Kung yung tinay po natin at yung andito ay pareho lang, ibig sabihin, lowest term na po yun at 1 lang po yung factor nila. Kaya, relatively prime. Ganun lang po yung pag-check natin kung relatively prime po ba at magagamit din po natin ito para malaman natin kung ano yung GCF ng dalawang number. So, let's proceed dahil pasado naman po ang ating A at N at higit sa lahat ang ating N ay positive prime number kaya we can apply rule number 1. So we have totient of n, which is totient of 13, is equal to n, 13 minus 1. So, totient of 13 is equal to 12. So, ganito lang po kadali kapag sa positive prime number ang ating n. Rule number 2. We have totient of PQ is equal to totient of P times totient of Q, where the GCF of P and Q is equal to 1. So, dapat daw po relatively prime ang P and Q. So, let's have an example. We have 2 raised to 28 is congruent to x mod 15. So, check po natin, ang A natin ay 2 at 15 naman ang N. Therefore, relatively prime dahil wala na po silang common factor maliban sa 1. Okay. So, pasok na po tayo para sa Euler's Theorem. Ngayon, i-check naman po natin kung pasok po ba tayo dito sa rule number 2. We have n equal to 15. So, ano-ano po ba ang factors ng 15? So, we have 3 and 5. Pero, meron din po tayong 1 and 15. So, ang factors po ng 15 ay 1, 3, 5, and 15, right? But, here, we will use 3 and 15. So, ano po yung point nito para dito sa rule number 2? We have PQ, 3 and 5 para po sa N natin na 15. Ibig sabihin po pala, ang P and Q are factors of Rn. Kailangang relatively prime sa isa't isa at factors po ito ng ating N. So, ito po ang rule number 2, which is pwede po setting composite. Since composite nga po ang 15. So, applying the formula, totient of 3 and 5 or 15 is equal to totient of 3 as P and totient of Q as 5. Please note na kailangan daw po na relatively prime din ang ating P and Q. So, our 3 and 5 are relatively prime kasi wala naman na pong ibang makakapag-divide sa kanila kundi 1 lang, right? So, ayan na po. Totient of 15 is equal to totient of 3 times totient of 5. So, paano na po natin ito i-consider? Remember that our 3 and 5 are prime numbers. So, we can apply rule number 1. Hence, totient of 3 is equal to 3 minus 1, we have 2, and totient of 5, and minus 1, 5 minus 1, kaya meron po tayong 4. Then, multiply, totient of 15 is equal to 8. So, ayan po. Totient of 15 is equal to 8. Totient of 13 is equal to 12. Pwede naman na po natin yung tandaan. Then, our rule number 3. Oh, by the way, i-remind ko lang po, our P and Q are factors of N. At dapat relatively prime sa isa't isa. Pwede na po dito ang ating composite number. Okay po. Rule number 3. Pasensya na po sa ingay. Totient of R raised to S is equal to R raised to S minus R raised to the quantity of S minus 1. Where R raised to S is a prime power. So, example, para mas maintindihan po natin. We have 5 raised to 28 is congruent to X mod 16. So, 5 and 16 are relatively prime. So, check. Positive numbers or positive integers, check. So, dito na po tayo magko-concentrate. Prime power. Rn, which is equal to 16, is a composite number, right? Then, i-break down po natin sa prime factors. And we have 2 raised to 4 na pwede na po nating i-apply dito dahil prime power, ibig sabihin, power ng prime number. And 2 is a prime number, right? So, pwede na po tayo dito. Remember that R raised to S is a factor of N. Kindly take note. So we have totient of 16 or totient of 2 raised to 4, carry lang, pareho lang naman, is equal to 2 raised to 4, r raised to s, minus 2 raised to 4 minus 1. Ayan po. Sinundan lang po natin yung problem. So, kapag ganito po, na composite, then breakdown natin sa prime factors, raised to a power, ito po ang ating gagamitin. Rule number 3. Then simplify. 4 minus 1 is equal to 3. So, 2 cubed, which is equal to 8. 2 raised to 4 is equal to 16. So, we have totient of 16 is equal to 16 minus 8, which is equal to 8. So, ayan po, totient of 16 is equal to 8. Ayan, nalinaw na po natin na ang r raised to s is factor din po ng n, just like rule number 2. Ayan po. So, we are done with our rules. Let's go to Euler totient function. So, ito po yung P times N na kinonsider po natin kanina. So, ayan. Yung mga sinold po natin kanina na totient of 16, totient of 15, ano po ba ang ibig sabihin nun? Ito daw po yun. It means the number of positive integers less than n that are relatively prime to n. So, mag-example po tayo para mas malinaw. Say we have n is equal to 5. So, the positive integers less than n are 1, 2, 3, 4. Nag-start po tayo kay 1 dahil positive. Then, need po nating i-check kung si 1 ay relatively prime kay 5, which is our n. So, 1 and 5. Meron pa po bang number na makakapag-divide sa dalawa maliban sa 1? Wala na po. So, 1 is check. Ibig sabihin, relatively prime to 5. How about 2 and 5? Ganon din po, wala nang makakapag-divide. So, check. Relatively prime kay 3 and 5. So, wala na din. Ganon din po sa ating 4 and 5. So, lahat po, 1, 2, 3, 4 are relatively prime kay 5. Hence, totient of 5 is equal to 4. So, ganito po pala ang ibig sabihin ng mga na-solve natin kanina. Yun daw po ay yung positive integers less than n na relatively prime kay n. Ito po ang ating n. So, nalinaw na po natin na ganito po pala ang ibig sabihin ng Euler totient function or the P times n. At meron din naman pong table, pwede pong guide. So, nakadepende po sa atin kung gusto po ba natin itong i-memorize. So, check po natin yung ating example. When n is equal to 5, totient of n is equal to 4, and we're correct. So, ayan lang po. Let's go to problem number 1. What does P times n count? So, ito po yung ating Euler's totient function na kakadiscuss lang po natin. Letter A, the number of integers from 1 to n which are relatively prime to n. Letter B, the number of integers from 1 to n which are factors of n. Letter C, the number of integers from 1 to n which are multiples to n. And letter D, the number of integers from 1 to 10 which are divisible by n. So, X na po tayo sa B, C, and D dahil relatively prime to n ang ating Euler's totient function, right? But, parang may discrepancy. So, recall po natin ang ating definition. It is the number of positive integers less than n that are relatively prime to n. So, tama po na relatively prime to n. Pero, meron po tayo ditong discrepancy kasi hindi po kasama ang n, rather less than n. Okay po? Pero, kung sakali po na ito ang lumabas sa ating actual board exam, ang sasagot po natin dito ay letter A. Hindi man po siya talaga ang tamang sagot, pero siya po yung pinakamalapit sa tama. Dahil ito po dapat less than, hindi from 1 to n. Kasi kapag from 1 to n, ibig sabihin kasama po si n. While dito po ay less than n. Okay po? Pero ito na nga po uulitin lang na ito po yung pinakamalapit. Ayan po. So, problem number 2. Which of the following statements is true when GCD of A and N is equal to 1? So, familiar, recall po natin ang ating formula and the consideration. So, siyang siya, and the answer is A raised to totient of n is congruent to 1 mod n. And it is B, 2 only. Ayan. Problem number 3. Which of the following can be solved using Euler's Theorem? So, balikan po ulit natin ang ating formula at ang ating consideration. As long as ang ating A at N ay positive, so positive naman po lahat, at dapat ang GCF ng A and N ay 1. So, yun ang ating i-check gamit ang ating calculator. So, kayang-kaya naman po ng mata-mata lang, but hindi po lahat pare-pareho ang kakayahan. So, gamitin na po natin ang ating calculator. Dito po, again, magiging relatively prime kapag kung ano yung tinype po natin dito ay siya rin ang lalabas dito. Pero kung hindi, ibig sabihin, meron pong lowest term, just like po nito. Naging 4/5 kasi divisible by 4, hence, GCF is equal to 4. Paano po nangyari? 16 divided by 4 is 4, 20 divided by 4 is 5. So, na-divide po siya ng 4, and the GCF of 16 and 20 is 4, not 1. So, eliminated. How about letter B? We have 7 and 15. Again, kayang-kaya po ng mata-mata lang. Pero dahil nga po hindi lahat ay pare-pareho ang kakayahan, kaya pinapakita pa rin po natin ito. So, 7/15 is relatively prime. So, check ang second. How about the third? We have 5 and 25. Sa taas po natin yung mas maliit na number. So, we have 1/5 dahil divisible by 5. So, the answer is 2 lang po, case 2. So, letter B. So, ganun lang po. So, at least sa pag-check po ng GCF para sa ating unit earners, hindi na po tayo mahihirapan kasi may tulong po ang ating calculator. So, problem number 4. Evaluate totient of 71. 71 is a prime number. So, pwede na po natin i-apply ang rule number 1. We have n equal to 71, so totient of 71 is equal to n, which is 71 minus 1. We have 70, letter B. So, ayan po. Problem number 5. Which of the following can be a divisor of 11 raised to 100 so that the remainder is 1? So, dito po, na iba naman, divisor naman po yung hinahanap. So, si modulo. We have this as our problem. 11 raised to 100 is congruent to 1 mod n. So, si n po ang ating hinahanap. And recall, we have this formula and this consideration and this one for our prime number sa ating n. So, kailangan din po nating masatisfy ang mga ito. Using our formula, we have 11 as A, totient of n as 100, then applying this one, we have totient of n is equal to n minus 1, copying this one for our Euler's totient function, 100 is equal to n minus 1. Then, solving for n, ililipat po natin doon si 1, kaya magiging n is equal to 100 plus 1, which is equal to 101, letter B. So, check po natin kung pasok po ba talaga dito. We have n equal to 101, a equal to 11. 11 over 101. So, 11 over 101. Ayan, pareho lang, relatively prime. So, check. How about n as a positive prime number? Check pa rin. So, we're good and it's letter B. Ayan po. Problem number 6. Evaluate quotient of 180. So, here, i-consider po natin ang factors ng 180. So, kapag ganyan, factors po agad ang ating i-consider. Then, 180 is a composite. So, kukunin po natin yung prime factors. Si 9, meron pa pong 3 times 3 at kay 10 naman ay 2 times 5. So, ito po ang ating prime factors. We have dalawang 2, dalawang 3 at isang 5. Ayan agad, prime power. So, we have 2 raised to 2 or 2 squared times 3 squared times 5. Then, our formula, we have 4, 5 dahil prime number, and this one for our prime power. Okay? So, applying the prime power, we have 2 squared minus 2 raised to 2 minus 1. Then, dito po, 3 squared minus 3 raised to 2 minus 1 times 5 minus 1. So, simplify na po natin. We have, so ito ay 1 na lang. 2 minus 1, 1 na lang po. So, we have 2 squared is 4, 2 raised to 1 is 2, 3 squared is 9, 3 raised to 1 is 3, then 5 minus 1 is 4. 4 minus 2 is 2, 9 minus 3 is 6, then copy 4. 2 times 6 is 12, times 4, we have 48, letter D. So, ganyan lang po. O, consider po muna natin ang factors. Then, i-check po natin kung anong rule ang applicable. Problem number 7. What is the remainder when 5 raised to 34 is divided by 17? 17 is a prime. 5 is a prime. So, GCF is equal to 1. Okay? Then, this is our problem. 5 raised to 34 is congruent to a question mark remainder mod 17. Then, the formulas. Ayan, dahil positive prime. Ayan. So, ayan. We have 5 raised to quotient of 17. Applying this is congruent to what? Mod 17. Then, solving this one, quotient of 17, ito po, is equal to n minus 1. Kaya, 17 minus 1, we have 16. Then, isa-substitute po natin ito dito. So, magiging 5 raised to 16 kasi yung quotient of 17 is equal to 16. Then, copy, congruent to 1 mod 17. Dito, we have to simplify the exponent just like our FLT. So, ilang 16 po ang meron sa 34? May dalawa po. At equivalent to 32. So, may kulang pa po tayong dalawa. Paano po natin ito gagawa ng equation? Gagamitin po natin ang law of exponents. Power raised to a power, a raised to m. So, we have 5 raised to 16. Then, ilang 16 nga po ulit? Meron po tayong dalawa. So, i-raise po natin ito sa 2, which is equal to n naman yung 2 natin. So, we will have 5 raised to 16 times 2 dahil a raised to m times n. So, paano po yung kulang nating dalawa? Ito naman po ang i-apply natin. product with the same bases. So, 5 raised to 32, then times 5 raised to 2 yung kulang natin. Then, i-add po natin a raised to m plus n, mabubuo natin ang 34. Naguluhan po ba? So, ito na po ang ating equation. 5 raised to 34 is equal to 5 raised to 16 raised to 2. Ito po yung meron tayong dalawang 16 sa 34. So, applying this one, ita-times po natin ito. So, 5 raised to 32. Then, dahil pareho pong ang base nila ay 5, ito naman po ang i-apply natin. Diba? Ito po ay 32 plus 2, then we have 34. Applying 5 raised to 16 is congruent to 1 mod 17. The remainder is 1. Hence, 5 raised to 16 is equal to 1. And 1 times 1 for 1 squared is equal to 1. And what remains is 5 squared na lang po. So, yung 5 raised to 34 ay na-simplify na po natin, naging 25 na lang. At kaya na po ito ng ating calculator. So, here, 25 minus 17, we have 8 as our remainder. So, letter C ang sagot. Paano po nangyari? Diba po, 25 divided by 17 is equal to 1. 1 times 17, we have 17. So, 25 minus 17, we have 8. That is why our answer is letter C. Ayan po. So, problem number 8. Find the remainder when 5 raised to 43 is divided by 16. So, ayan, pasok na po ang ating composite. And here is our problem. 5 raised to 43 is congruent to question mark remainder mod 16. And ito po, tulad po kanina, ang factors po ng 16 ay 2 raised to 4. So, alam na po, we can apply the prime power rule. Number 3. Ayan. Then, we call the formulas. Ayan. GCF must be equal to 1. Then, ang ating prime power. Ayan. So, we have to check na dapat to po ang ating A at N ay relatively prime. So, we have to verify if 5 and 16 ay simplest form na po ba or lowest term. Dahil kapag lowest term, relatively prime na po. So, yes, goods po tayo dyan. So, proceed po tayo. Ito po ang i-apply natin. Dahil prime na po ang 2. Si 16 na composite number ay ni-breakdown po natin sa kanyang prime factors. Kaya nagkaroon po tayo ng 2 raised to 4. 2 times 2 is 4 times 2 is 8 times 2 is 16. So, we will apply prime power rule. So, quotient of 16 or 2 raised to 4, pareho lang naman, is equal to 2 raised to 4 minus 2 raised to 4 minus 1. Kaya nagkaroon po tayo ng cube. Then, 2 raised to 4 is 16 minus 2 cube is 8. So, 16 minus 8 is equal to 8. That is why quotient of 16 is equal to 8. Ayan po. Then, applying this 5 raised to quotient of 16 is congruent to 1 mod 16. Dahil ang n po natin ay 16. Applying quotient of 16 is equal to 8, we have 5 raised to 8 is congruent to 1 mod 16. Then, just like po kanina, we have to simplify exponent na 43. So, ilang 8 po ba ang meron sa 43? We have 5, then remaining 3. So, we have 5 raised to 43 is equal to 5 raised to 8 times 5 times 5 cubed. 8 times 5 is 40 plus 3, we have 43. Applying 5 raised to 8 is congruent to 1 mod n. So, 1 po ang ating remainder. We will apply it here. So, 5 raised to 8 will be 1. And 1 raised to 5 is also 1. Hence, ang naiwan po ay 5 cubed. 5 raised to 43 is equal to 125. 5 cubed is equal to 125. Kaya 125 po ang andito. 125 rather. Therefore, yung 5 raised to 43 po natin ay papalitan na po natin ng 125 dahil na-simplify na po natin. Then, kaya na po ito ng ating calculator. 125 divided by 16, we have remainder of 13 and it is letter A. So, ayan po. Nalito po ba dito sa ating last part? So, we can apply our calculator techniques. We have our formula A minus A divided by B times B. We have our format A mod B. Ang ating A ay yung value before the congruent sign at ang ating B ay yung ating modulo. So, mod B, mod 16, B is equal to 16. By the way, mod 4. So, let's input. Ayan, applying our calculator techniques. Mod 4. Then, ang A po natin ay 125. 125 minus A, 125. Then, divided by our B is 16. Then, times 16 equals sign 13. Ayan po, agad-agad, remainder na po yung makikita natin. So, we are correct. So, ito po, kailangan po nating ma-master ang ating Euler's Theorem. Then, combination of our calculator techniques, then we're good to go. Again, it is 13, letter A. So, this is all about Euler's Theorem. Hope meron po tayo natutunan at may apply po natin sa ating board exam. Thank you for watching, teachers. Kindly share so we can help more self-review takers. God bless po sa exam. Malapit na. Manifesting and claiming March 2024 passer.